Hello, I welcome you all. The problem reads, the spring has a stiffness of 50 newtons per meter and an stretch length of 0.3. If it is attached to the 2 kg smooth collar and the collar is released from rest at A when theta is equal to 0, determine the speed of the collar when theta is equal to 60 degrees. The motion occurs in the horizontal plane. Neglect the size of the collar. This problem is coming from the engineering dynamics 14th edition by R.C. Hibbeler. Engineering mechanics dynamics 14th edition by R.C. Hibbeler. Let's draw the free body diagram. Of course, we'll have the weight, and let's say this collar is exerting some force on this rod. We expect normal force from the rod to the collar, and also from the side of the spring. If we section this spring, let's say somewhere there, it's tensioned right now. I see stretched, so you expect some tension force like so. Right? And therefore, some normal force also in this direction. Let's say it is the normal force in that direction. Okay. Assuming as it is getting tension like so, it is exerting a force on this collar, and the collar in return is reacting, producing this normal force. If this assumption is wrong, then the calculation will correct it, but we are not calculating any of this. So this, let's call it normal force 1, let's call this normal force 2, or maybe let me not. All right, that is fine. 1, then this one, let's call it, this is of course the weight. Right, so this is the horizontal plane. So let's say we call this point A, then let's call this point here B. This is just for purposes of calculations. So we have the spring when it is at rest, theta is equal to 0. So we'll call this length is LR. So we have two lengths. Let me show them. We have this one like so, and we have also this one. Okay, right? So let's call this as, this one we call it as LA, and then we call this one as LB. Okay, all right. So let's say LA is equal to, so if this is a semicircle, it's going to be equal to 4. Then LB is just going to be equal to, LB is equal to 4 cos theta, right? 4 cos theta. Is that not so? No, not really. Let me check. So if we took this that there like so, this one becomes a right angle, right? Not so. That one becomes a right angle. Therefore, of course, this becomes 4 cos theta. Right, it's okay. Okay, this is 4 cos theta. All right. Okay, so let's apply the and then we have L original for the spring, which is just 0.3. Okay, so let's apply the equation using the conservation of energy. So we're saying kinetic energy at point A plus potential energy at point A is just equal to kinetic energy at point B plus potential energy at point B. So T, like we said, is the kinetic energy, which is always positive, and V is the potential energy. So we have two types here: gravitational potential energy and elastic potential energy. So TA here, the kinetic potential energy at M is equal to 0 because this system is starting from rest. Then VAG, gravitational, let's say the horizontal plane is the datum. Okay, therefore VAG is just going to be equal to 0. And VAE is equal to half K LA minus LO squared. Then TB, kinetic energy at B, we expect to have something there. Okay, so it is half MVB squared. And then VBG is just equal to 0. And then VBE is just going to be equal to K AB minus AO squared. So let's replace this. We put them in one equation. I'll just write those without zeros. So I'll have half K LA minus AO squared is equal to half MVB squared plus K LO squared. Let's replace this with numbers. We do have K, which is the spring stiffness, and then LL is a 4 minus 0.3 squared. This is equal to half times the mass, which is a 2, and VB squared plus 50. There's a half there. I forgot a half. How did I forget a half? So there we have a half. So here we have a half. Okay. So half 50 by 4 cos 60 degrees minus 0.3 squared. Therefore, our VB is just going to be equal to 0.5 by 15 by 4 minus 0.3 squared minus 0.5 by 50 by 4 cos 60 minus 0.3 squared and divided by 0.5 by 2. Okay, then square root of answer. This gives us a 16.43 meters per second. Alright, I guess we are done. We have found the speed of the collar when theta is equal to 60 degrees. Great. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.